Welcome back, everyone. So in this video now, I will talk about the question about the analysis of the characteristic of the rational function. There are a lot of information about this rational function. So let's take a look at it and see what's going on. I have a question here, say that find the domain x-intercept, y-intercept, and the homes. The reason why we should analyze this function, because to be able to see its characteristic as well as sketch its graph. The basic graph I show you in the first video is just the basic one, but we have a we might have a complex rational function more than that, much more than that. So let's take a look at how we're going to analyze this characteristic and the behavior of the function. So before I get into it, let me recall about the basic function, right? So this is just recall, right? Recall, we have a function basic 1, y equal 1 over x. And we know that its shape is somewhere around like this, is invariant point 1 and 1. So if x equal 1, y equal 1 divided by 1, which is 1. So we know that. The same like here. If x equal minus 1, then y will be equal minus 1, right? Now, we also know the behavior of the function is if x is getting large, both sides, positive infinity and negative infinity, right? Then the graph will go somewhere like this. And this is in the first video, we have seen this, right? And I explained everything about this already. So now I just assume that you already know about this. We're going to keep going. So now we know for this basic function, the vertical asymptote is what? X equals 0, right? X will cross this line. And the horizontal asymptote is y equal 0. So it means that at x equals 0 for this basic function, the non-permissible value will be x equals 0. So as long as our denominator equals 0, then this rational function does not exist at that point, right? When the denominator equals 0. So this is for the x. But if we have a whole equation, we do the same. We say, therefore, for x plus 12 will be, whether you can say different from 0 and then you solve for x, or you can set it equal 0 and then you solve for x and you say x cannot be that number, will be the same, right? So let's set up the equation and solve for x in that way. It will be easier. So I'm going to move the 12 over. So I say 4x will be equal minus 12. Divide both sides by 4. Then this will go on, and x will be equal minus 12 over 4, which is minus 3. So as long as x equal minus 3, then this is the vertical asymptote. Because at x equal minus 3, if we put in here, we have minus 3 times 4, which is minus 12. Minus 12 at 12 is 0. Yes. So therefore, as long as the x value equal minus 3, any other value are acceptable, just like this one here, right? Except x equals 0. Here, except x equal minus 3. So let's draw the vertical asymptote. C minus 1 for this function, right? Not for the basic one anymore, but for the new function. So minus 1, minus 2, minus 3. So our vertical asymptote actually go through this line. And this line is x equal -3. That is the vertical asymptote. So now we find out vertical asymptote. What else do we have to find out? We're going to find, actually, I'm missing here, should be vertical asymptote and horizontal asymptote. So let's find out horizontal asymptote. Now, the horizontal asymptote for this function is this line, right? Because we know that the function never touched this line, which is y equals 0. So now we have to find the value where the y is not allowed to exit, right? So in this case, how do we do that? So this is because you haven't learned limit, right? Because at this level, which is Mark 12, you haven't learned limit. We can look at this example through the concept of limit as well. But let's say that if you haven't learned the limit, so let us analyze like Mark 12, right? Let's say if x is approached to a very large number, because when you look at the y function, you want to find the horizontal asymptote. So let's say horizontal asymptote, right? Let's say horizontal asymptote is this line. Something like this will be horizontal asymptote, right? So the horizontal asymptote tells us that whatever the y function cannot touch this one, cannot go through this. As well as this here, whether on the top here or down here doesn't matter, as long as it's not touching this line, right? And it go like this. Let's say like that. Let's say this is horizontal asymptote. That's how it means, right? So how do we find the value of y right here? And how do we know whether the y equals this line? Or maybe this line down here, maybe down here, which is y equal -5, -6, whatever. Or here is y equal 1 or y equal 2, whatever, right? We don't know. Now we're going to figure out where is this horizontal occurred. Where is the y value it's going through, right? Here at the example, it's going to 1, y value is 1. But maybe it not go to 1, maybe it goes to down here, maybe -5, -4, whatever, we don't know. We're going to find it out. And how do we find it out? The way we find, we will look at the behavior of the y function when the x value approaches to a very large number, positive infinity or negative infinity. And actually this concept leads to the limits, which is you will learn it in calculus, right? But let's look at here. Let's say if x here getting a very large number, then in this fraction, what is the significant value of the x here? The degree, right? If x here is the power 1, then we look at the x power 1. If x is power 3 or power 4, power 5, we look at where the x is supposed to be a big number, which is the degree of it, right? So here we have a degree of power 1. So it means that any number behind it, like -9 here, let's say if you have an x is million or 6 million or 100 million, right? We call a positive infinity, right? Very large number. And if you take away -9 from a 6 million or 100 million, that doesn't make any difference, right? A little bit number 9 is so insignificant compared with the large x number. So therefore, to find the behavior of the y value where the x approach to the positive infinite number here, we can ignore on the number is not significant here. And we should focus on the degree of the x. If the x is a square or power 3, power 4, or just power 1 right here, right? So this x can be substituted by 1 million times with 3, which is 3 million. And you don't care about take away 9, right? So assume, right? Assume, okay? assume x getting to positive infinity, then your y will approach to what? Approach to 3x. Let's ignore this number for now, over 4x, right? Because the x is the one who makes a difference. Whether or not it's big or small is based on the x. It's not based on the 9 here, it's not based on the 12 here. So we can ignore this 12 and ignore this 9. Pretend it is only have 3x over 4x. Then the x with the x is the same degree, it will cancel out, and we're left with 3 over 4. So that tells us that if x is approached to a big number here, positive infinity, the y function will approach to 3 over 4, which is 0.75. So maybe 0.75 is above 0 line a little bit. So 3 over 4 is about here. So now we know that our horizontal asymptote will across the y at 3 over 4. And this is the value of our horizontal asymptote, right? Here. This is our horizontal asymptote. That is how we look at the positive when x approaches to positive infinity. What about when x approaches to negative infinity? What happens? So if x approaches to negative infinity, then negative divided by negative is same like positive, and the x will cancel as well. So the y is still approach to 3 over 4. So on this left side, the horizontal asymptote the same, which is this number line, where the y equals 3 over 4. So based on this observation, we can make a statement that the horizontal asymptote of this y function or the y behavior will be, so we say look at x approach to positive infinity and negative infinity, then y will approach, the arrow show approach, right, to 3 over 4. And this is horizontal asymptote for this rational function. So now we have both of them. We have a horizontal asymptote, this one, and the vertical asymptote, this one. So we fulfill this task here. What now we're looking for, now the domain is the same like this, right? Because we know that x cannot be across this number. So let's state the domain as well. So the domain is a set of x, such that x cannot be minus 3, where the vertical asymptote approach, which is this line right here, right? And x can be anything else, so belong to real number. And that's how we state the domain for this one. Now, how do we find the x-intercept? Now, anytime you have a point on the graph, let's say that point here. The point here have two coordinates, x and y. Now, obviously, this point have to be stay on the y-intercept to be the y-intercept, right? So at this point, the x have to be 0 so that we have the y-intercept. Otherwise, it will be just out here like that. It's not going to be like that, like y-intercept. The same like x-intercept, the same we have the point right here as the x-intercept. Then the y here have to be 0 so that the x will become an x-intercept. And the y here have to be 0. So therefore, to find the y and the x-intercept, we just set one of them equal 0. If we find x-intercept, we set y equal 0. If we find y-intercept, we set x equal 0. Based on this understanding, right? So now, I'm going to say here, set x equals 0 to find y-intercept. And let's do that. So we have y equal 3x minus 9 over 4x plus 12. So if x is 0, we say 3 times 0 minus 9 over 4 times 0 plus 12. So everything here will become 0. 4 times 0, 0, cancel out. And divide both sides by both top and bottom by 3. We have the y-intercept equal minus 3 over 4. So minus 3 over 4 is the y-intercept. And therefore, the y-intercept, the x will be 0, because that's how we set it, right? And y equal minus 3 over 4. So this is the y-intercept for this rational function. Now, let's find the x-intercept now. How do we find the x-intercept? We will do the opposite, which is we will set y equals 0, right, to find the x-intercept. Now, how do we find, we set y equals 0? It means this function here, 3x minus 9 over 4x plus 12 will have to be equal to 0, right? Because this is the y function, right? So y equal this and equal this, equal 0. Now, you must also realize that the denominator down here, of course, it cannot be 0, but also it can be anything. As long as the numerator equals 0, then we have a function like 0 over whatever number here, doesn't matter. Let's say the number here is 5, this equals 0. If this denominator is minus 1,000, this one still equals 0. So the numerator is a factor, is a factor decided the numerical value of that fraction, right? The denominator down here does not matter. So therefore, to find the x-intercept, we set the y equals 0, and we only care about the numerator, and we don't have to worry about the denominator. So therefore, we will say, if we want the y value equals 0, then the 3x on the top, then the 3x minus 9 have to be equal to 0, right? That's the reality. So as long as this numerator on top is 0, 3x minus 9 equals 0, then the whole fraction will become 0. It means the y will become 0. So therefore, we solve for x to figure it out. And we move this over. We have 3x equal positive 9. Divide both sides by 3. X will be equal to 3. So now we know the x-intercept is x equal 3. And of course, the y have to be 0. And that's how we set the numerator equal 0 to find for the x-intercept in rational expression. Okay, so I hope that you understand it, right? Now, so therefore, I told you there's a lot of information to analyze this rational function. We are at the math 12 level, so there's a lot of information, right? It's not hard. I know that a lot of you already learned this, already go through, and you might forget. So this is a review for you. For those students in advance, you just learn from grade 10 or grade 11. You can watch this as well to understand in advance, right? Okay. So we find what we do. We find vertical asymptote, we find horizontal asymptote, we find y-intercept, and we find x-intercept. Now let's talk about the home here. What the home mean? This example doesn't give you the characteristic of the homes. But I can explain what the home means to you, because maybe one of this will show us what is the whole number is, right? Or maybe in another example. But let me explain what is the whole first, okay? This is the whole first. So to explain that, I need to draw the graph. And if I don't draw the graph, then it's hard to explain it, right? So let me pretend that we have a graph, okay? And maybe not quite a true graph, but just to demonstrate what the whole means. So we know this is horizontal and this is vertical asymptote of this rational function, right? So maybe our function will look like this and maybe look like this, right? Now the whole mean, there is a value in here where the function approaches like an empty circle, a blank circle, and this we call a whole. Or if we have a rational like this, then all of a sudden in the middle way here, it have a home here where there's no y value exists, right? Nor either x value. Or actually x value is exist, right here. But the y value doesn't exist here. So therefore we have a home. And this is we call a home. Now in this equation, in this rational function, we don't have any home. The home only occurs if you can cancel out the top and the bottom. But then you will get into that in some example I will show you, right? So here I just explain graphically what's the home mean to you. Now we're done with this. Let's continue with the question here. And let me erase on this messy here. Okay. So maybe we can borrow a part of the ball here. We need it. Just analyze about vertical asymptote, horizontal asymptote, and x-intercept and y-intercept. But none of the questions are the same. So therefore, I have a few examples in here to show you all of them so that you get into the lesson to get more ideas and you'll be able to do it on your own. If you happen to purchase my courses online. Okay, so let's do the question E here. So the letter E here is y equal 3 plus with a function, rational function. Now, the whole thing here is a function, right? So we know that our function has a whole number here, but adding with this function, so it's still a rational function. Now, how are we going to find the vertical asymptote? So, of course, by looking at it, you know the vertical asymptote will be when x equal 4. Because 4 minus 4 is 0, right? So that symbol, now we know that. What about horizontal asymptote? To find horizontal asymptote, we're looking at y when x approach to positive infinity and negative infinity, approach to a very large number, right? Because that's how the horizontal asymptote occurred, right? Something like that. So here is positive infinity and here is negative infinity. So this is the horizontal asymptote. So we have to look at the y value when the x approach to a large number. Now, for that, you know that y will approach to 3, adding with 5 over the number 4 here you can ignore because if you have an x is very large number, let's say million, You take away 4 is the insignificant value, right? So we can ignore that and we just say 5 over positive infinity. And this will give you 3 adding with 0 because we have small number divided by a very large number. 5 divided by million equals 0.00 something, right? So it's just 0. So therefore, our horizontal asymptote is y equal 3. Because y will approach to this 3 value when x approach to a big number. Now, if it's a negative infinity, we'll get the same value, right? Because 5 divided by negative big number is just 0. So 0 doesn't matter negative. Of course, it's still 0, right? So that's how it happened. Okay. Oh, sorry. This one, I put it with the purpose. Okay, so based on this behavior, we know that anytime you have a value of a whole number here, and with the fraction with one single egg at the bottom like that, then if you set x is very large, this fraction will become 0, and therefore y equals 3 is our vertical horizontal asymptote. So therefore, if fractional fraction happen in this form, you will know right away what is a horizontal asymptote, which is y equals 3 equal this whole number right here, right? But now the question is the same, but similar pattern will make you understand that, right? Okay, so now let's finish this question. So now we find out vertical, horizontal asymptote. Now let's talk about x-intercept and y-intercept in here. So to find x-intercept, we set y equals 0. So let's set this number equals 0 on the left-hand side. 0 equals 3 at 5 over x minus 4. So now I have to solve this equation for x, right? To find x-intercept, we have to have an x value. The y, of course, will be 0 already. So therefore, we have the equation like this. So I'm going to move this 3 over, and minus 3 will be equal 5 over x minus 4. So do like this, I can isolate the x here, right? Now, I am going to kick this bottom here, go up here. The reason because I kick it to the other side of equation. I twist the operation, divide become multiply. Now somebody will explain to you multiply both sides by x minus 4. And then you cancel out anyway, right? So it's the same idea. But except that when I explain, like if you move this up, right? You kick this number up because divide become multiply, you twist the operation. Adding becomes subtract. Subtract become adding. Divide become multiply. It's the same idea. Like you multiply both sides by this bracket. It just is shorter. So I will get like this. Equal 5. So now let's solve for this equation. So I will have 3 times x is minus 3x. Distribute up here, I will plus 12, right? Minus 3 times minus 4 equal 5. So now move this over, minus 3x equal 5 minus 12, right? Positive become negative. So that will be equal minus 7. So minus 3x equal minus 7. Divide both sides by minus 3. I get x equal positive, right? 2, 1 over 3. So this is the same like 2.33. And the x-intercept equal 2.33 and y is 0. I put in the point form, right, of the coordinate form. So that is the x-intercept. Now, how do we find the y-intercept? To find the y-intercept, we set x equals 0. So to find y-intercept, we set x equals 0. So if I set x equals 0, let me borrow a little bit here. Then the y here will be equal to 3, adding with 5 over 0 minus 4, which is equal to 3, adding with, actually subtract 5 over 4. Now, the common denominator will be 12 minus 5 is 7 positive over 4. So that will become yes, 7 over 4. So that will be equal 1, 4 down here and 3 up here. So 1.75 positive, right? Yes. So now we know the x is 0 and the y-intercept is 1.75. 1.75. So that is our y-intercept. So our x-intercept is here, and our y-intercept is here for this question. What else do we look at? So we have this and this domain. Now, the domain for this question, you can state from here, right? Because the domain happened when the vertical asymptote occurred, because we don't allow for the value of x equal 4, right? X can be any number as long as it's not 4. So we say domain is, and let's just put D for now, right? Is a set of x such that x cannot be 4 and x can belong to the real number. But as long as x cannot be 4. So that is the domain. So this is the analysis of our rational function of this one. So now let's continue with this one here. Now this one, I leave it for now for a moment. So let's do this one here. Now by looking at this expression, I figured out that maybe I can factor this, right? So I'm going to factor the top by 3. And inside, I will 3 times 3 equal 9 minus 2 times x. Down here, this is the form of a squared minus b squared, which is the form of differences squared. The answer for this will be equal to this formula, a plus b times a minus b, right? So that is the formula. So now we're going to apply this formula to factor this expression. And we call this is the factor of differences squared. And therefore, when you, sorry, it popped up something. I have to change it. Oh, sorry about that. Okay. So when you multiply these two brackets together, you get this expression, a squared minus b squared. So our a will be 2x, right? Because that will become 4x squared. So our a, we have two brackets here, and our a will be 2x. Our b will be 3, because 3 squared is 9, so it will be minus 3, and 2x plus 3. Now at this level, you know how to factor differences squared, right? If you forget, I review a little bit, but I don't want to go deep into it because we will not have time to go through all of this, right? And therefore, I told you math is approaching of the one level at the time, right? Okay, so now we have this two bracket. So let's look at our vertical asymptote. What is our vertical asymptote? Our vertical asymptote will be 2x minus 3 equals 0. Now, as long as one of this bracket equals 0, the whole thing here will become 0, right? Because 0 times with anything is 0. So let's solve for x by setting one bracket equals 0 at a time. So we're going to move it over. 2x equals positive 3 x equal 3 divided by 2, divide both sides by 2, right? Equal 1.5. Now, we also have this second bracket. So 2x plus 3 equals 0, move it over, 2x equal minus 3, and x equal minus 1.5. So we have two vertical asymptotes in here. That is our vertical asymptote. Now let's talk about horizontal asymptote. So horizontal asymptote means look at y when x approach to positive or negative infinity, a very large number. So by inspection, I know that on the top I have degree 1 of x. Down here I have a degree 2 of x. Now the number 9 here is insignificant if I set x is a large value, right? So assume that this estimate that will be equal minus 6x divided by 4x squared, right? Now the 9 here is insignificant, so we ignore this number at the moment. When we set the x is very large, what we care just about the highest degree here. Now obviously I can cancel this factor, become minus 2 over 3, right? And on the top, x will gone, the bottom will become, minus 6 over 4x, right? Because x1 cancel out with x2 down here. So obviously this is same like this. And of course this will approach to 0, right? 6 is small number divided by a large number. Now this is 0, so it doesn't matter negative or positive, right? So what the y equal? The y will be equal 0, right? Because this is the y function. And so when we set x very large, the y approach to 0. So our horizontal asymptote for this is y equal 0. Now let's find out the x-intercept. So what are x-intercept? So to find x-intercept, we set y equals 0, and therefore okay, before we do this, but let me see, it's okay, we just continue, okay? So to find x-intercept, set y equals 0. So now I know that the y equals 0, then what happened? Then 9 minus 6x supposed to be 0. Remember I told you the numerator is the one we care, because as long as the numerator is 0, then the whole fraction here will be 0. Doesn't matter what down here. So as long as we set the numerator to 0, we can solve for the x-intercept, because the y here will become 0. The whole thing will become 0 if the numerator is 0. So now we solve for x. So move it over, we have minus 6x equal minus 9, change both of them positive, divide both sides by 6, we have x equal 9 over 6, which is divided by 3, reduce low fraction, x equal 3 over 2. So the x-intercept is equal 1.5. So let's put in the point form of x-intercept, 1.5 and 0 for y. So that x-intercept. Now let's find out y-intercept. So y-intercept, we will set x equals 0, right? So if we set x equals 0, what do we have for this fraction? This fraction will have 9 minus 6 times with 0 over 4 times with 0 minus 9. Now 9 minus 9 will be equal minus 1, right? Because this here is 0 and 0 here. So 9 divided by minus 9 is minus 1. So our y-intercept will be x equals 0 and y equal minus 1. So that's how we find out all of this. Now what about the hole? We haven't talked about the hole yet. So let's look at the holes in here. I have to borrow a little bar in here to solve for this question. And that's why if you miss anything in here, you don't have time to copy it down. You register to my math course online, you have everything. Okay, so let me borrow a little bit of the bar here. Oh, I forget, I erased this one as well. So let's talking about the home here. What's the home mean? The home mean when the function, let's say something like this, right? That's the home, and then go like this. So this is the home occurs. And how do we know when it occurs? Now, if we try, we would know. We look at it, right? But let's find out by algebra, because we want to analyze this from the algebra perspective here, right? So the home occurs when occurs when we can cancel out the top and the bottom. And what do I mean by that? So let's look at this function in terms of the bracket. We have two brackets at the bottom. If as long as we can cancel one on top and one at the bottom, then we're okay to find the whole. But how do we know that? This is 3 minus 2x. This is 2x minus 3. They're not the same. They twist position, right? But I'm going to manipulate a little bit. I'm going to say if I multiply top and bottom by minus 1, then I'm not changing anything, right? I allow to do that in fraction. I'm going to distribute this minus 1 into here. So on the top here, I will have 3. And this fraction will change. Minus 1 times 3 will be minus 3. Minus 1 times minus 2x will be positive 2x. And down here, I still have this thing. But now, because I change this, become minus 3 and positive 2x. Minus 3 and positive 2x. With the compensation of the negative 1 at the bottom here, I have to keep it, right? This one I distribute to, so that I get that. So it means I can cancel this one with this one now because they look the same, right? So now this y will become 3 on top, but the bottom will be negative outside, and that will be 2x plus 3. So by doing this, I reduce the big chunk algebra on the top, cancel by the bottom. Now, I know now is the home will occur at 3 minus 2x, or maybe use this one, 2x minus 3, right? 2x minus 3. And if this home is occurred at 2x minus 3, then because I can cancel this, right? I say occurs when we can cancel out the top and the bottom. So when we cancel out the top and the bottom like this, we know that we have to find the x value where the home occurred. So to find the x value when the home occurred, all what I do is I'm going to set this expression become 0 and solve for x. So I will have 2x equal 3, and x will be equal 3 divided by 2 is 1.5. So I know my home occurs at x equal 1.5. But what about the y? I will base on this expression because 1x equal 1.5, then this is the y value we got, right? So I'm going to calculate the y value for the y coordinate for the x when x equal 1.5 because I know x, the home occurs at x equal 2x minus 3 at this bracket, right? And I solve for x. I know that x occurred at 1.5. So let's set up this x as 1.5 and solve for this. So we have minus 2. 2 times x is 3 over 2. Okay. Now let me multiply the negative inside, right? So I will have minus 2x minus 3 if I multiply this, right? So let's substitute the x by 1.5 and see what the y happened. So the y will be equal to minus 2 times with 3 over 2. I turn out into bracket, okay, fraction. 1.5 equal 3 over 2. Minus 3. So it equals 3 over, this 2 will cancel with 2. So I will have minus 3 and minus 3 will become minus 6. So that will give me minus 1/2. So now I know the home at x is 1.5 and y is minus 0.5. So that is the home value. So that's how we can find the home value. So just remember, as long as we can cancel the top and the bottom, that is where the value of the home occurred. And when the value of the home occurred, we can use the simplified equation to find the y value of the home. So we set the bracket where the home occurred at 0 to solve for x. And we substitute into this expression. 1 is already canceled. Then we find the y, where the x is 1.5. So that's how we do the home. Now, let me give you another example. And I want to finish this video, right? This is kind of long video. So what the video I have here. So let me summarize before I finish this video. So in other words, we have to look at the vertical asymptote, horizontal asymptote. To find the vertical asymptote, you look at the denominator, set the denominator equals 0, and solve for x. At that point, you know that x is non-permissible value, and that's where the vertical asymptote occurred. Now, to find the horizontal asymptote, you will look at the behavior of this y function when x approach to a very large positive or negative infinity. And you just look at the x degree, ignore anything else insignificant value, and substitute the x equal large value in here to find the y. When x approach to large value, whatever happened to y, that is your horizontal asymptote. So then you will proceed to find x-intercept by setting y equals 0. To find y-intercept by setting x equals 0 and solve for it. To find the homes, you will look at the expression. If you can cancel the top with the bottom, that is where the home occurs. So that is how summary it is. Now I'm going to give you another example, right? And I want to show you another example of the horizontal asymptote. Let's say you have the equation like minus 4 adding with 5 over x plus 1. Now you know right away, horizontal asymptote is y equal minus 4. And why like that? Because you look at this value, right? When you know that this fraction here will become 5 over like that. And therefore, this fraction will approach to 0. And therefore, you're left with this. And this is your horizontal asymptote. So at long as you have a rational function with the form like that, it's so easy to look at the horizontal asymptote. You don't even have to calculate or manipulate or anything, right? Just look at here and understand this concept to figure out horizontal asymptote. Now, you're not going to memorize it, but you have to understand it, right? Like this. Okay, so let's say, for example, if I give you a rational function like this, y equal minus 4x minus 7 over x minus 1. And I asked you to figure out, find the horizontal asymptote. How do you figure it out? You don't have a form like that. But because this is the binomial, but the degree is just power 1, so it's very easy to manipulate, actually. You can transfer this form into this form. And how do we transfer that? Let me show you. So let's say I'm going to manipulate. I would say, because I want to have something like x minus 1 in here, so I know that I have to factor something with the minus 4. So I'm going to put it like that. Now, when I put it like that, actually, let me try another way. So I know that as long as I have x minus 1, then I can cancel with it, right? So I'm going to say this top, I will say 4x minus 4. I toss in a minus 4 on the top. But the minus 7 is still there. Now, when I do like this, if I subtract 4 on the top, I have to add 4 so that it balances out. So minus 4 add 4 will become 0. So then the numerator is still 4x minus 7. I'm not changing anything, right? That's how I manipulate it. So now I will say, for this one, I'm going to put them in bracket. And I'm going to factor out the x. So I factor out the 4. So I will have minus 4. And in here, I will have an x. And actually, I should add 4. And therefore, this number should be negative, sorry. So I will have x minus 1 if I factor out the 4, right? And because I factor out this already, so I'm going to add these two guys together. I'm not changing anything, right? So that will be minus 11 on top. So now this fraction turned out that I can split into two fractions, which is 4 times x minus 1 over x minus 1, subtract 11 over x minus 1. You can join or split fraction like that, right? So this, you can cancel it. And by doing this, I will change this, become, this cancel out, so I left with 4 minus 11 over x minus 1. And now I look at this and say, oh, so my horizontal asymptote is this. So by doing a little bit manipulation like that, you can figure out the horizontal asymptote easily, right? So that is the end of video. I just want to show you how we can manipulate the algebraic expression to find out the horizontal asymptote. But I'm not going to go through all of this because this I already taught in the other question. Okay, so I just toss in a little bit extra bonus here so that you can see that sometimes given you a rational function like that, And if you have problem with figure out if x is approach to positive infinity, then this is another way you can manipulate and figure out the horizontal asymptote. Now, this one is not as easy at this, at thinking about putting the x is a very large number here. And just looking at this, and you can see that obviously your y is this number here. Now, y is negative and this is positive. Let me see. Oh, -4, sorry. So this is my mistake, sorry, my bad. So y equal -4 by looking at this number, right? Because if you set the x is very large here, you set the x is very large number here, so you just care about this 4x over x. You don't care about 7 and 1, right? So 4x divided by x is actually -4. And that is how the y, the vertical, the horizontal asymptote occurred when x equals -4. So that's another way of looking at it. So I hope that you enjoy this long video. Now this is too long. You can, if you register to my course, you can watch it and you can stop it at some point and come back and watch it another point. But I want to make my points go through, right? The whole thing, and because we have to learn how to sketch it as well in the next video. So I want to get it done in this video. So thank you for your patience watching a long video hour. That's how much we have learned in Math 12 and the calculus. I cannot to be so rushed, right? Cannot teach you for so fast and rush through it. So I teach very slowly, but I make my point step at a time, right? And I hope that you enjoy it. Bye for now. So thanks for watching.